Okay, so Mr. Freed showed you previously in lesson 3-5 operations on matrices, which included addition, subtraction, and scalar multiplication. But today we're going to talk about matrix multiplication, which takes two matrices and multiplies them together with conditions. So an example that might be easier to start with is we're going to have tickets, okay? We're going to have tickets in the orchestra seating, the mezzanine, and then the balcony. So that's where they're cheaper, okay? And then we have the number of tickets of sold at our venue on Thursday, Friday, and Saturday, okay? How could we find the revenue in total from each day? So for example, on Thursday, there was 150 orchestra seats purchased. Mezzanine was 125 and balcony was 60. Knowing these amounts and knowing these prices, how could I find the total revenue for the day? Okay. So, I have this row here of all my prices. And I have this column here of all my ticket sales. I know it's $7 per ticket, so I'm going to multiply them together. And then it's $6 per ticket, so it's 6 times 125. I'm adding them together because I'm trying to find a total for the whole day. And then balcony is $5 per ticket, and there's 60 balcony seats. So when I add them together, my total for the day is going to be $2,100. Okay, so if I want to know for each day after, I just repeat the process. I take my row to my column, and then I would take my row to my new column until you exhaust all of your columns. So I'll show you on the next page what that would look like. So, we had a 1x3 matrix. I tend to write the dimensions as I go to give myself a guide. We took a row and we multiplied it to each column, then added them together to get only one entry. So, when we do this, we end up with a 1 row, 3 columns. Well, before, with orders of operations with matrices, we had to have the exact same dimensions. We don't have the exact same dimensions here. So why was I allowed to take a 1x3 matrix and multiply it to a 3x3 matrix? I ended up with a 1x3. There might be some confusion as to when I put 2,100, do I put 1950 here? Or do I put it here? Well, if you're moving to the next column, your entry should go into the next column. Or another way to set it up is to figure out what you're going to end up having. Okay, you're going to end up having a 1x3 matrix. So you can kind of set up that framework to know where you're going to put your entries. Okay? Let's see if the next few matrices are able to be multiplied together, and if so, what are the dimensions? So, we notice that it's rows by columns. So the columns in the first matrix have to be multiplied or the same as the rows in the second matrix. So since they're the same, we're good to go. we are allowed to multiply A and B. What will we get? A 3 by 5. Now, if I reverse the order, would I be able to multiply them together? These aren't the same, so no. The next one, yeah. And lastly, yes. Okay, here's an example in your notes. I don't know if it's directly where your notes are, the next problem, but it is in your notes. It says, explain why you cannot multiply these two together. Well, I like to see the dimensions of my matrix. That is a 3 by 3 and a 2 by 3. I cannot multiply these together. The dimensions are not compatible. Or you could say the columns in the first matrix do not line up with the rows in the second. If I reverse the order, then yes, they could be multiplied together. It says find the product if possible. So I like to start out seeing my dimensions. Okay, it's possible. I know I'm going to end up with a 3 by 2 matrix, so I like to set up my framework. It's going to be 3 rows, 2 columns. Okay, all right, you take your row, put it on your column. It's like pouring into the next column. 1 goes to 2, 3 goes to 6. So 2 plus 18 is 20. Row to column, row to column. 1 times 5, we're starting a new column, so I'm in a new column. 3 times negative 3. 5 and negative 9 is negative 4. When I've exhausted all my columns, my row goes down to the next row. I'm going to go row to column again. 4 times 2, negative 2, and 6. New row, new row. So 8 and negative 12 is negative 4. Row to column again. 4 times 5, negative 2, negative 3, gives you 6, and 20 is 26. We've exhausted our columns, so we move down to the next row. Row to column. 2 times 0 is 0. 1 times 6 is 6. 0 times 5. 1 times negative 3. Negative 3. Are we correct? We ended up with a 3 by 2. Yes, we are. Okay, let's try some more. Okay, if at any time you want to pause the video to try it on your own and rewind, go ahead. We have a 2 by 2 matrix here. We should end up with a 2 by 2 matrix here because the other one's a 2 by 2 matrix. Our answer should be negative 14, negative 4, 16, and 3. You take your row to your column, your row to your column. Row to your column, row to your column. Let's try a harder one. All right, this seems so simple. The students have a hard time with it. This is a 2 by 1 and a 1 by 3. So oddly enough, we're going to end up with a 2 by 3. Two rows, 3 columns. So set up my framework. It's kind of weird because it's so simple. This is our row. It's just a single digit and our column is just a single digit. So -5 and 1 is -5. There's not much adding going on. Well, row to column, row to our new column. -10, we're in a new column, so we're in a new column. -5 to -8, +40. So we're getting so many numbers because we're literally just multiplying and not adding things together. 7 and 1, 7 and 2, 7 and -8. Are we correct? Yes, we are. All right, last one. We have a 3 by 3 and a 2 by 3. So we will end up with 3 by 3. Okay? So take your time. Oh. Is this gonna work? No. Nothing would happen. -2. 12. There's nothing there. That's why we can't do it. They have to line up because the numbers have to be there. It's not possible. Okay, your assignment's at the end of your notes. You can start it now or you can wait till class tomorrow to do it. If you have any questions, let me know. Bye.